What we are talking about today is this, unless there are questions, is this book 6 Degrees, which I want you to read for the midterm. So to just kind of get things started, I've got this iClicker thing going, and I'm interested to see what your reactions to the book are. Those of you, how many of you have started reading it? Excellent. A lot of you. Good. Very good. So 6 Degrees. Do you find it convincing and frightening, or hysterical and unbelievable, or scary, but you're going to withhold judgment for now, perhaps, waiting to see what you learn in the rest of the course? Maybe it'll all turn out to be, believable or unbelievable. Or D, you haven't started it yet. Let's see what everybody says. Well, not too much for the hysteria. It is a, I mean, the author definitely, toward the end, he does kind of get, emotional. There's a lot of really charged sentences in there, sort of poetic, heart-tugging kind of sentences. But in terms of the science, it's a pretty good book. The guy is not a scientist, but he's a very careful journalist, and I didn't find much in it that is wrong. There are scientists I know who object to the tone a little bit because they think it's not right that a scientific issue should be presented in a sort of a heart-tugging sort of a way. But in terms of substance, I think it's I personally think it's a pretty good book. So given that you find it frightening, what is it that you find the most scary? Drought and water issues are sort of one class of thing that are in the book, or heat issues like heat waves, storms, or sort of biological issues like extinctions and health problems, or just the sort of liberal hysteria that you might find there, that maybe that's the scariest thing if you have a particular, viewpoint. So what do you think? Drought and water issues is sort of coming in, and then health are the strong ones in your opinions, and I'm pretty much with you on that. The book starts out with, before we talk about these individual particular issues, let me sort of set the stage a little bit. The book is it has this organization of 6 degrees are the 6 chapters. And the 6 degrees are the temperature changes for the whole, the Earth as a whole that are expected by the year 2100, giving these different scenarios. So they have these scenarios. Well, what if population growth does this and economic growth does that? None of these scenarios actually include any sort of effort. They're all sort of business as usual scenarios. So none of them include any what they call mitigation, any effort to cut CO2 emissions. So these are all kind of, if climate wasn't an issue, if we didn't care, these are sort of the range of what could happen. This yellow or orange one right here is actually a scenario for if the CO2 concentration in the atmosphere stopped rising today. So if it stayed at 385, what you see is that there's a little bit of more warming that is expected over the coming couple of decades. In other words, we haven't gotten all of the warming that we've paid for yet. And the reason why it doesn't warm instantly is because the ocean holds a lot of heat. And right now, the oceans are taking up heat, and they're sort of keeping the planet cool, and it takes decades to kind of warm up the ocean. So that's called committed warming, and that's sort of at the low end of the scenarios if we all stopped emitting CO2 tomorrow. And then these other ones are, various levels of economic growth, and the most aggressive growth scenario is this thing they have these sort of cryptic names, A1, F1. I don't know, you don't have to know what these all mean, but this is like the worst one, the highest CO2 growth, And the range of that from the different models kind of gets up towards 6 degrees. So these are the 6 degrees that make up the chapters of the book. So 6 degrees is by 2100 is it's on the fringe of what's possible. It's not like the whole thing is inevitable. I guess I would make the point, I personally find myself just flattened into catatonic despair whenever I look at this book, right? I mean, basically, it's pretty overwhelming. But I would make the point that most of this is avoidable. It's not technologically a difficult problem. The difficulty is getting everybody to cooperate. It's sort of a tragedy of the commons thing. So we'll talk about energy and carbon cycle and all that stuff in the next part of the class. But none of this is absolutely foreordained to happen. Although there has already been some warming just in the last few decades, since about 1970, since about here to there has been about 0.6 degrees of warming, and even if the CO2 stopped rising, it would rise, the temperatures would rise up to about 1 degree warmer than the natural climate. So we are already sort of deep into chapter 1 in the book. The stuff that he talks about in chapter 1 is all stuff that we should be seeing in the real world already, and pretty much I think that's true. So that sort of sets the stage a little bit. Now, what are these temperatures? It's hard to know. I mean, a few degrees C warmer doesn't sound like a big difference. It's a few degrees C warmer out there today, right now, than it was 6 hours ago, and the sky isn't falling exactly. But when you're talking about the average temperature of the Earth, the changes are much bigger than they sound, just based on degrees. So there is one point of comparison is the glacial interglacial cycles. So this is an ice core record of CO2 concentrations and other methane and things like that going through the last 800,000, well, what is it, about a little more than 600,000 years into the past. And you see this sort of, so here's the present now, and if we look at this bottom one as sort of like a record of how much ice there is and temperature, we're in an interglacial time now, which is warmer, and here's the last glacial maximum about 20,000 years ago when there was a mile of ice over us in Chicago, or some big amount of ice. And so that was a huge climate change. I mean, it was a different planet during the last ice age. And the average temperature of the Earth was about 5 or 6 degrees colder during the ice age. So that gives us sort of a calibration point for, what 5 or 6 degrees is. It's a huge change. I mean, you'd know the difference from outer space looking at the Earth, because the sea level was much lower and there were these huge ice sheets. North America and Northern Europe were kind of like Greenland is today, just covered with these huge ice sheets. A big change. Looking a little closer in time to within the interglacial time that we are in, there are reconstructions of the average temperature of the Earth that are done using, actual thermometer was invented in the year 1860, so there's no thermometer data from 1850 or anything like that before then, but they can piece together temperatures using the width of tree rings and chemical measurements of little shells in the ocean and in lakes, and measuring the temperature down inside ice cores and in the Earth. There's a bunch of different very clever ways that people have put together to figure out what the temperature of the Earth was going back in time before there were thermometers. And these are all of those reconstructions. So here's the present, and going back to, over to about 1,300 years ago, there are these various reconstructions of the average temperature of the Earth. The first one that was ever done was this one, MBH. So that's Michael Mann. And he was the first to try to put together this global average temperature based on tree ring data. And it's hard to tell which is which, but his happens to be one that's pretty much flat through here, and then it jiggers up at the end, and it's what they call the hockey stick. And the hockey stick is has come in for considerable sort of abuse. Michael Mann he's a combative guy. He's the kind of guy who would stand out in a thunderstorm and say, "I dare you to strike me down, God." Only he's doing that not to God, but other people on Earth, and they try to strike him down. He was subpoenaed in front of Congress, and they were asking him, where you get your funding anyway, boy, and kind of kicked him around a bit. But it has been vindicated that his conclusion that it's warmer today than it has been in thousands of years. More recent reconstructions have more sort of natural climate variability in the past. So this period right around the year 1000 AD to about 800 to 1300 or so, this is a time called the medieval warm climate, or the medieval optimum climate. So the Vikings sailed the ocean. Astonishingly, they went all over the place. They sailed all the way down to the Mediterranean to get salt. I don't know why they didn't concentrate salt out of seawater right off of Norway, but they didn't. They were all over the place. And the years of the Vikings, driving around the world, were exactly coincident with this medieval warm sort of climate interval. And then following that was a time period called the Little Ice Age. Not the big ice age like the last glacial maximum, but a little ice age that was maybe a half a degree colder than the medieval warm time, or maybe 1 degree colder, something like that. But you could ice skate on the rivers in Amsterdam, and it was a noticeably different climate in Europe. The Little Ice Age was caused by the sun. This was a period when there were fewer sunspots, and that indicates that the sun was not quite as bright as it is today. And so that's what they think is why it was a little bit colder there. But the point here now is that, again, we can use this as sort of a calibration point for what a degree C feels like, a degree C of global temperature. So, a half a degree or 1 degree between the medieval warm and the Little Ice Age was a noticeable change. It wasn't the end of the world, but it was definitely something that affected, the trajectories of civilizations and things like that. So, 1 degree C is a pretty big part of that plot, whereas the plot for the future goes all the way up to, potentially 6 degrees C. So it's starting to look bigger now, I hope, if you are comparing it to these other sort of touchstones. So the first thing that was the first little interlude in the book, in chapter 1, had to do with drought. And most of you thought that the drought and water issues were sort of the scariest part of the book and the climate change forecast. And I tend to agree with that. Slightly warmer temperatures, if the heat gets too much, it can kill the corn crops, and people do die in heat waves. But if things dry out in continental interiors and stay dry for more than a year or two, there's basically nothing for it. You can't live if you don't have enough water. So it's funny that drought is a part of the global warming forecast in a way, because rising temperature by itself means that the air holds more water vapor, and that tends to lead to more rain overall. So that's kind of like the first order prediction is globally you expect there to be a little bit more rainfall in a global warmed world and not less. But it turns out that in continental interiors, oh dear, I need the stick. They have a special stick here. I'm sure the guy who designed this room, the architect, whoever it was, included this stick because you can't reach up there. I'm sure that that was all planned for. It turns out that in continental interiors, there is a sort of excess evaporation, which is a sort of more than the precipitation. And so you do get this sort of drying in spite of the fact that overall it's sort of rainier planet in a sort of global warmed world. So the way it tends to work out in the models is that places that are wet will get even wetter, and places that are dry today will tend to get even drier. So I can show you a picture of what that looks like. This is a map of results from climate models. So the IPCC, in making these scientific assessment reports, solicited various climate modeling groups around the world. Everybody run your model for this particular set of, forcings, and then we can compare. So it's a way of like finding if there are bugs or biases in the models. If some group has made some stupid mistake with the clouds or something like that, that sort of thing tends to come out when you're, comparing all these models. And now lots of papers are coming out using all of the models together to try to get, the best guess of what the response will be. And that's what these people did. They put together all of the models and then tried to figure out where there would tend to be drying. And there are these particular regions around the world that are particularly vulnerable. Yes? Yeah, so in general, the red places on the map are places that are drying out. That's just the way to look at it. So the reds are, this is a trend in precipitation. So how the rainfall changes per degree C of warming is how they sort of processed all this. I mean, I don't know why they did it particularly that way instead of, some other sort of metric. Presumably they tried lots of different ways to make it come out, as coherent as they can. The truth is that drying in continental interiors is sort of a regional effect. And it's pretty easy to get the global average change from putting more CO2 in. But if you ask what's going to happen exactly in Poughkeepsie, New York, or sub-Saharan Africa or something, the models tend to disagree more. Regional climate is much harder to predict than global. So this was kind of an impressive plot for me when it first came out, because precipitation changes had always been kind of chaos between one model and another. And so they've managed to find sort of a coherent picture that makes sense out of all of these models. That's kind of a newish development, that the models are getting to the point where they can do regional things with any sort of reliability. So the areas that are projected to dry, there's the American Southwest, which is a big part of that first interlude in the book. There is the Amazon, which could collapse. That was in chapter 3, I think, that the Amazon and the Indonesian jungles, rainforests have a tendency to kind of reinforce their own existence by evaporating water. So water lands from rain on the ground, and it either runs down to the ocean or it is re-evaporated to the air to then rain again. So plants tend to suck up water from the ground and then transpire it, which means evaporate it and recycle the rain. So a rainforest kind of stabilizes its own existence by recycling the rain. Actually, grasslands and regular forests, all kinds of plants sort of do this. And so if you clobber the trees, you get less rain, and it tends to sort of lock into a drought condition. The same thing happened in sort of the Dust Bowl, that you get drought, and all of a sudden it's too much for the grass, the vegetation to keep up, and it dies, and then the soil gets all hard and cracked, and it doesn't hold water anymore. So it tends to flip into this kind of drought state and stay that way until you get lots and lots of rain to sort of help it flip out. So it's kind of a tipping point. That's a real charged phrase in this whole debate, tipping point. It kind of gives me the heebie-jeebies a little bit, but this is a real example of a tipping point. So let me show you some model results here. This is from one of the models. Here are simulations for the last 50 years or so, and it's showing on both of these plots, the solid line is the percentage of the land surface which is in a drought condition. So drought is tricky to measure because it's all about how much water a landscape is used to. So if someplace is dry naturally and it's dry this year, you don't call that a drought, you just call that the way it is. But if it has less rainfall than it's used to, then the plants sort of suffer and agriculture doesn't work, and that's what you call a drought. So diagnosing a drought is not a trivial thing in one of these climate models. It's not just how much rain you get. It's sort of this whole larger picture. But what they're finding is that the planet has generally, since about 1980s or so, has kind of flipped into a more droughty sort of condition. So Australia has been in drought. The northwest or southwest US has been in drought. And in general, they're finding that the whole planet is kind of more drought-stricken than it was in the earlier part of that record. And their model is basically sort of capturing that. But then the scary part comes when they shoot this thing forward in time. So this is the area of land that is in drought condition, and there's this really light line at the bottom, which you might be able to see is extreme drought, and then the solid heavy line is severe drought, and then moderate is sort of up here. And so what you see is that the area of the land surface in their model that's in drought goes up from, say, 10% today to like 40% by the end of the century. So that's kind of sobering. The drought section in the book is also kind of illustrative of how the forecast is not built just on model simulations, but also on sort of records from the past, what they call paleo data. And one of the examples of this is this place. This is the Sand Hills in Nebraska. And they have vegetation on them now, but if you dig just a little ways down in the soil, what you find is sand. So this whole area was a dune field during the time of the medieval warm climate. So medieval warm climate was great to be in Europe, but in the southwest of the US, it was a time of drought. There were, they looked at drought occurrences in sediment cores, in lakes and in the ocean. And they found several sort of decade-long, really intense droughts around this time that coincided really, really frighteningly with the collapse of the classic Mayan civilization. So the drought in this area during medieval warm time was extremely severe. This is our breadbasket now, Nebraska, and if if it looks like the Sahara, that's a bad thing. And then sort of a little bit closer in the past is the Dust Bowl. So the Dust Bowl was a period of like 20% decrease in rain in Oklahoma, and so the plants pooped out and the soil became sort of dried out, and it actually just blew away. There were huge dust storms, called it the Dust Bowl for that reason. And so you can see the deposition of all this dust that's sort of, and something like 85% of the people that lived in Oklahoma at that time left, because you just can't live if there's no water. And then there's also drought in the Southwest today. This is a photograph of Lake Mead, and you can see that the water level used to be kind of up at this level, and it's way, way, way down now. The American Southwest has been in drought for the last decade or so. Kind of, it gives some credibility to this forecast. One of the aspects of water that gets clobbered by climate change seems to be monsoons. So monsoons are driven by differences in temperature. Differences by land-ocean temperature contrast. So if you have warm surface over land and cool surface over the ocean, the air will tend to rise up, and when it rises, it cools and the water condenses, and so it rains. And then it comes back down over the cooler part over the ocean. And these monsoonal rain systems are subject to disrupting by changing the temperature patterns around the world. The other kind of rain is like little thunderstorms. There are particular places around the world that are called storm tracks, where you have lots and lots of thunderstorms. There's one kind of going off into the North Atlantic from the U.S. And there's just sort of general, stormy, little convective. So maybe some little piece of land gets lots of heat, and so it rises up and then makes a cloud and rains, and that's kind of just a local thing, land only. This doesn't seem to be as affected by climate change as these sorts of monsoon systems that are kind of like driven by the larger scale patterns of temperature around the world. So the American Southwest, which has all this powerful evidence of drought during the medieval warm time and in the present, and is actually a monsoonally driven rain system, is what I'm told. And then there are others. There is the big monsoon. You say monsoon, and the image that comes to my mind is movies from India, the Indian monsoon. They came up in the 2-degree chapter, and they actually are predicted to be stronger in a warmer world. whereas the American Southwest was in the 1 degree chapter, reflecting the fact that it started already and it is getting weaker. Yes?
I'm actually from Tucson, Arizona, so I'm familiar with monsoons. But my question is, since it's driven by land / ocean temperature process,
Yes.
driven by the Pacific, or how is it happening in the middle of Arizona?
Well, yeah, so it must be the Pacific. Yeah, it must be the differences. So it's a large scale sort of thing. So the land, like going all the way to San Diego, and then the Pacific, for 1,000 kilometers or something off like that. It's a large scale. It's a large scale thing. Yeah, that's right. You stand in Phoenix and wonder where you can go surfing. It's not so easy, but yeah, you're right. So it's a large scale. These are large, sort of planetary scale things. You could draw them on a globe with a piece of chalk or something. Okay. And then the Sahel in India, or in Africa. Is sort of in North Africa on the fringes of the Sahara Desert, is in the 1 degree section, and it's thought to get a little wetter. And then there's a monsoonal circulation in China's highlands. Which is came up in the 2 degree section, and it gets a little drier. And then there's the effect on the forests, especially rainforests, which have this tendency to sort of lock in the drought conditions by, they evaporate water and perpetuate their own existence if there's enough water. But if the conditions change, even if the conditions change slowly, forests tend to collapse very suddenly, sort of abruptly. So there used to be a rainforest in what is now the Sahara Desert. And you can trace it by looking at pollen grains in lake sediments or in sediment cores in the ocean. And that rainforest collapsed suddenly in the early part of our interglacial time, about 8,000 years ago. So it's thought that rainforests in the future, if they are going to collapse, will do it in a sudden sort of way. So there were a number of them in the book. There was Queensland, Australia, which was in the 1 degree chapter. And then there's the sort of Amazon and Indonesian rainforests, which were in the 3 degree chapter. I mean, none of this is certain when exactly this would happen, but these are just the estimates that the author was able to dig out of the climate simulation literature. Now, one way that a rainforest could suddenly collapse is by fire. If things dry out, they become ripe for fire. There were huge fires in Indonesia a few years back. Not only forest, but also peat deposits, carbon that was in the soil that managed to somehow get exposed to the air and burned. It burned for months, and there was smoke, that had a huge impact on the people. I mean, it was a lot of smoke, and it was actually a lot of carbon that was released. You can see the Indonesian fires in record of atmospheric CO2 concentration or concentration of other smoke-derived chemicals like carbon monoxide. So one possible sort of end game for these forests is they finally are too dry, and then the wrong spark hits, and they sort of burn suddenly, and then adding that carbon to the atmosphere is going to amplify the future warming. And then there's another water issue that is discussed, which is mountain glaciers and snowpack. And so what benefit these bring to us is that they capture water in winter and release it in summer when it's most needed. So an example of this that's closest to home is the Pacific Northwest in this country, the Cascades. The snow melts slowly over the summer, and then when you need the water for agriculture to grow all those apples in eastern Washington, that's where that water comes from. Lima, Peru is almost entirely sustained by snowpack water. But the biggest example actually is in the Himalayas, that are the source waters for the Indus and the Brahmaputra and the Ganges rivers. A huge snow area up there that provides water. So Al Gore said, this is one of the things I learned from his movie, is that half of the people in the world get half or more of their water from mountain snowmelt water. So where you come up with half the people in the world is you got to go to India and China, because that's where the people are. And so that's what he was talking about. That was news to me. I hadn't heard that before, but I checked it out later, and he wasn't wrong about that. So there's a figure in the textbook that shows what mountain glaciers have been doing. So this is a compilation. We've got the year is down here at the bottom, going from 1500 AD to 2000. So this is a long span of time. And the vertical axis is the length of these glaciers in kilometers, but what the guy did who put this together was he sort of didn't put any numbers on that. I mean, this figure is replotted from a paper that was published in Science or something, so that he could sort of spread things out so you could see all these different records kind of laid out, against each other to see whether they're getting longer or shorter. And what you see is that they're all getting shorter. Also, what you see is that a lot of them started getting shorter hundreds of years ago. So this one here, for example, in about 1850, it started to decrease, and here. So some of this decrease in the length of glaciers is due to natural climate variation, the end of the Little Ice Age. But there's been this sort of surge of melting most recently, which can only be explained by the warming from people. We'll talk about why scientists think that the warming since sort of 1970 is attributed to people. We'll get to that sort of later in the class. We haven't really made that argument yet. But so one of the sort of poster children for mountain glaciers is Mount Kilimanjaro, which is melting just catastrophically. It'll all be gone in a couple of decades. And that particular case is hard because it's there's not real good weather information from around there, and it could be that Mount Kilimanjaro itself might be impacted as much by changes in precipitation as by changes in temperature. So that gets attacked, as sort of an icon. These climate scientists say it's all warming, but actually it's agriculture or something in Tanzania, which is affecting Mount Kilimanjaro. That could be, but there are all these other ice sheets all around the world, and they're all decreasing. Yeah. Well, the CO2 in the atmosphere was holding quite steadily, quite happily at 280 ppm, and now it's 380 and rising, and that's because of us. So, that's sort of clear. There are these natural climate variations that we'll talk about, and they do affect society, but, they weren't the end of the world. What we're talking about for the future is huge, though, compared. You can read people say that the medieval warm climate was a good time to be in Europe, and that's true. It was a benevolent climate in Europe, but that was a degree or half a degree of warming, and that's a totally different beast from 5 degrees or something in the future. You got to sort of beware of the bait and switch there. So there are also, in the book it talks about storms, and it's supposed to be stormier in a warmer world, so the air is warmer and it therefore holds more water vapor, and the water vapor is the fuel for a hurricane, right? We talked about that. So if you ramp the whole thing up, storms could get more intense. Hurricanes, extreme rainfall events, things like that. This is already observed. This is a result from model simulation of the intensity of hurricanes. So the solid lines here, now the open circles here are for normal, natural CO2 levels, and then the solid circles are for doubled CO2 levels. And what you see is that it's sort of shifted the bell curve a little bit toward higher intensity storm. So the way you can measure the intensity of the storm is by the minimum air pressure on the inside. We said last time we were talking about how storms are driven by the low pressure as the air sort of tries to fill in the hole, but then it goes around in circles because of the Coriolis effect. So how deep is the hole tells you sort of how strong the storm is. And the whole thing shifts a little bit, towards stronger storms. But the important thing is to look at the really big ones, the Category 5 storms. And what you find is that the number of the really intense storms goes up in this prediction with warming. Actually, and this has already been observed, but it's a little dodgy actually, because if you compare the intensity of the storms with the temperature changes, actually the storms are getting stronger more quickly than the theory even predicts. So they don't understand everything that's going on here, and it's kind of hard to predict other than just kind of in a qualitative sort of way what we're talking about for the future. There are health impacts, and a good summary of health impacts comes from what's called Working Group 2 of the IPCC report. So if any of you ever have to do this seriously, all the information that you could possibly want has been sort of put together and summarized and very heavily reviewed by this IPCC, and you can download these chapters and read them if you need to. So this is from a summary from Working Group 2, which is about impacts of climate change, which this whole book and lecture is about. And so here they are. There's positive impacts and negative impacts, but the negative ones tend to outweigh the positive ones. So there's this guy, the skeptical environmentalist Bjorn Lomborg, and he makes a big deal out of how fewer people are going to freeze to death in a global warming world. And that's true. So that's a positive thing. That's that little blue arrow there by the hand. But there's a lot of other stuff going on here. Malaria is affected by public health as well as by mosquitoes, but this is not a good picture, no matter how anyone tries to spin it for you. So to sort of sum up, I've heard conversations and read speculation among climate scientists of how they envision the world being. One report I read said it would be like Mad Max without all the feathers. I didn't like that movie all that much. Another said Soylent Green, and I personally detest Charlton Heston, so I just couldn't go there. But there was a movie called Children of Men that described sort of breakdown of civilization. You get sort of failed states and authoritarian response. I mean, when you start putting the human context into all of this, it gets really ugly. So on that cheerful note, I will leave you to go venture out into the rain. I'll see you on Monday.